And the little subheading under this is of combined polygons. Last year we called this complex shapes, I believe. AKA complex shapes. And that means this. You're going to be asked to find the area of a shape that we don't have a singular formula for. For example, this one. In the real world, we do have a formula for this, but right now we don't know it. 8, 6, and 4. 8, 6, and 4. Let's say these are inches. And you are asked to find the area of that. Well, we don't have a formula to find the area of that trapezoid. So we have to do what I like to call, anybody know what I like to call this? Divide and conquer. And sometimes you have a choice of how to divide the shape. In this case, not so much. In this case, the basic way you're going to do this is, you are going to draw a line straight down from here. Get a right line, and you're going to have this rectangle. You're going to find the area, and you're going to have the area of this triangle. And it would probably be a wise idea if you don't want to write whatever sentences and stuff. You could label this here. You could say the area of rectangle A, and you're going to add to it the area of triangle. Let's call that triangle B. And then you'll get the total area of it. And it's pretty quick, simple, and painless. What is the formula for the area of a rectangle? Well, that equals length times width. What is my length? What is my width? 6 times 4, which is 24 for my rectangle, correct?
Yep.
The area of triangle B, the formula for that is 1/2 base times height. Now here's where you have to be a little careful. If you're looking for the dimensions, we know the height of the triangle is in fact 4, but how far is it from here to here? It's not 8, because 8 is the whole line. You have to take that little 6 away from 8, and this would be 2. So it's 1/2 of 4 times 2. Half of 8 is 4. When you combine them, as all good farmers would, you get 28. This was 24. This was 4. So the total is 28 inches squared. We did stuff like this, I think, last year. I don't think that should. It shouldn't cause you great consternation. Whatever. I don't think. And then we have one more exciting one. Jot down this one more problem, just because they get a little. Welcome to the world of geometry today. Check out this problem here. Draw this one as best you can. See if I can get this to draw. I've got this shape here, and let's label it A, B, C, D, and E. A, B, C, D, and E. By the way, if you like what we're doing here, you'll like geometry, because that's what this is really. And I know that this is a right angle, and I know that this is a right angle. Now, one thing you can ascertain from this, because we know, we've got 2 triangles there, right? Charles, yes or no? I have triangle ACD, and I have triangle ABE. What do I know about those triangles? Now, notice that they both have a right angle. They both have angle A in common. And because this and this are the same, and the same angle here, that means angle B and angle C are the same. Which means, what do I know about those 2 triangles, Olivia?
proportional.
Yeah, they're proportional, or we call them similar, which I think we use this little sign here, which means their sides are going to be proportional. So here's what the book says. It says AB is 40 centimeters. Segment AB is 40 centimeters. Side DC is 30 centimeters. Point B is the midpoint of AC. B is midpoint, or the middle of AC. And does it say something else? No. Find the perimeter of BCDE. BCDE. We are looking for the perimeter of BCDE, which is this thing. I'm looking for the distance around this shape right here. So that means, I know this. Let's write down what we do know. We know that AB from here to here is how long? 40 centimeters. And I know that DC from here to here is 30 centimeters. How am I going to find out this and this? Somebody have some suggestions for me. I'll give you a key right here. Is some important information. If B is the midpoint of AC, which means it cuts it in half, then you know what, Kevin?
That AC is 80 centimeters and BC is 40 centimeters.
Right, you know that this would also be 40 centimeters. And you could add those together to get AC as well. But I'm looking for this side in particular. So I know, now I know 1, 2 of the 4 I need to know. Anybody? You should be able to tell me this. Why? If you think about those triangles separate, let me separate and draw them here. Here's the little guy. I'm going to find a place where I can write. Here's the little guy, A, D, E. And here's the big guy, A, C, D. I know the little side is 40. I know the big side was 80, right, because we added those together. And I know the big side here is 30. Because these are similar, you should be able to tell me what this side is here, because what's the scale factor, Ephraim?
It's 15.
It's 15 because this triangle is half of that triangle, half of 80, half of 30. So now I know 3 of my 4 sides. Here is where trouble, which is my middle name, comes in. How am I going to find out that last side? If you can figure out this, or that, you can figure out that last side because you know it's half the long one or it's twice of whatever the short one is. Anybody? Wait a minute, what's going on? Did I write something down wrong here? No, it says 40. 80 is 40. Oh, boy. Sorry, children. Wait, I have to change this because the book. Well, let's do it the way it is, but you can't get a good answer now because I goofed it up. This should have been AD was 40. I guess we'll change it. Let's change it. Because that'll make it a little bit here. AD is 40. Sorry, this all goes away. Otherwise, we're going to have to do something goofy. Which means this is 20. How am I going to find out these? I guess now is the question. Which means this is 20 here, right? 20, 20. Sorry about that. That'll make everything all messed up. Anybody? Anytime you're looking for lengths of right triangles, you should think of what? Brenda Massey? And is there a Pythagorean theorem that has a 15-20? Or let's do the big one. Is there a Pythagorean theorem that has a 40-30? Let's look, let me draw it over here. This is 40, this is the big one again. 40 and 30, so you reduce it by, divided by 10, you get this little thing that's 4, God bless you, and this little thing that's 3. What is it, what type of triangle? 3, 4, 5. So what does this side have to be? Because you have to remultiply by 10, it should be 50. And if the whole thing is 50, the whole thing is 50, this little part right here is 25. So to find the perimeter, you'd add 30 plus 25 plus 15 plus 20. Kind of messed it up by putting that dimension in the wrong place. But I think that's a valuable lesson for us all to learn. Number one, the teacher is not infallible. To pay attention to the thing there. So when you add it all up, the perimeter is this. What is that? 2, 4, 6, 90. Whatever it is, centimeters. Again, if you like it, that's kind of geometry. If you don't like it, too bad. All stuff you have to experience. Perfect. Then, tell you what.